Okay, I hope the voice in this session will be better than the previous one, and I'll try to improve on that. So in our previous session, I mean the first session, we had a introduction to what we are going to do, and let's recall and recap what we are up to. We have processes, we have events, and we have interactions, and all those things generate data. We use this data to make machines learn, and then we found that data may exhibit different characteristics. And we also came to the conclusion that statistics is going to help us to understand those characteristics of the data, right? And then today we are going to do some hands-on with MS Excel for mean, mode, and median, which are quite basic, and then standard deviation and variance. Before we switch to the Excel, let's have a brief discussion where we are going to lead ourselves now. So as we found in our previous session that two important aspects of the data, one is centrality of the data and one's variability of the data. Centrality of data tells you where the center of the data is. Like we discussed a bit about the mean, and we can also find center of your data using mode or median, which are quite which are quite simple techniques to do away. And then we can find the variability of data, how spread the data is, which we can do using standard deviation or variance. So some useful facts about mean, which we will see and we will do in Excel, that if you scale the mean, scale the data, the mean will scale accordingly. And if we translate the data, the mean will also translate. And some of the sign differences from the mean is always 0. And we will see each one of these things in using Excel as we progress today. Now, this is a quite important thing to understand is when you have a number of means, number of techniques, or number of ways to find the center of your data, or as we found that we can use mean, we can use mode, or we can use median. Then if we have multiple ways to find the center of the data, which one you should opt for? So centrality, find the centrality or the center of the data, or the which measure of centrality you should use. We have taken an example, which I want all of you to read out. For example, if Bill Gates adds $250 to the mean per capita wealth in the United States, but nothing to the median. For example, if we look at the per capita income of people in the United States, and if you add the income of or the wealth of the Bill Gates to that whole per capita income, then it will really, it's going to change the mean or the average wealth of each person of the United States, of the persons in the United States, or the people in the United States. So that will dramatically change the mean. So if Bill Gates makes you personally feel richer, then you can use the mean, but you should know that this is not going to help. This is not going to make you richer because Bill Gates lives in the United States. That will not make you richer. So mean is not a good measure of finding the center of that data. So rather than finding using mean, what we should rather do is we should look for median, right? So the median is not going to change even if you add millionaires and billionaires to the population, and by adding those will not change anything about the median. So you should, before using any measure of centrality, you should be sure that there may be some influence of the outliers or the influence of the values which are very extreme, that you need to keep into your mind before going for the centrality of data. Now, as we know, we can use mean, mode, or median to find the center of the data. Now, the second thing which we are worried about is the variance. Variance is the spread, how spread your data is. Now, let's talk a bit about the variance. You should know every measured quantity. Every major quantity, whatever you are going to measure, is subject to some level of variance, right? Even if the situation is unchanged, if the situation does not change, still, if you're going to measure something today, and if you are going to measure the same thing tomorrow, there will be some sort of variance in that measurement. And this is natural. And there are so many circumstances, actually, we are not able to model. That's why we find some. Now let's take an idea of variance. Now this is the data which I have taken from internet. Now this data tells you about the birth weight of the babies, and this is, we have they have taken a sample of 3,226. You can look at here. We have 3,226, and the mean, as our doctors tell us, that the baby should be around 3.5 kgs, at the time of the birth. So the mean is 3.39, the data which you have in front of you. And the standard deviation is 0.55. Now, what is the standard deviation? Here we have the mean. Mean is here, okay, in the center of the data. Now, standard deviation tells you that you can have a variation of, you can be away from the mean 0.55, right? So half a kg up or half a kg down from the mean is okay, right? That's okay. For example, someone weighing around 3 kgs is okay, and someone weighing around 4 kgs is okay. Let's say we are just half a kg away from the mean, or half a kg is lesser than the mean. So this is variance. Now, if you look at this example, this is a natural process. We have babies, that's a natural process, and you can see there's always a variation, even in a natural process, right? So we have to assess, we have to be sure about the spread of the data, how you may deviate from the mean, how you may deviate from the center of the data. To assess that thing, calculate or measure that thing, we should have a scientific way of measuring that variance, measuring that spread of the data, right? So how do we measure this variance? Um, we use standard deviation and we use variance, which is another name, I should say, to the standard deviation. It's just the square of the standard deviation, right? We will see it once we move into that, right? Now, this is a very important concept that's called empirical rule, right? Empirical rule tells you that, like I told you that day in the previous session, that 70%, so we have a 68 actually, to be very precise, we have 68% of the data lies within the vicinity of the mean. Within the vicinity, I mean, say, is one standard deviation away from the mean, just a single standard deviation away from the mean. You can see this in orange color. So if you add 34 on the left side and 34 on the right side, this adds to be 68%. So 68% of the data is always one standard deviation away from your mean, right? And 95% of the data, that's why we call this rule, we call this rule empirical rule, or 68, 95, 99.7. 68% of the data falls within one standard deviation. 95% of your data will fall in just two standard deviations away from the mean, and 99.7% of the data fall within the three standard deviations away from the mean. So if you look at this image which is in front of you, you have a spread, right? And this spread tells you it's a bell-shaped spread or a bell-shaped distribution. We will not go into mathematical details as of now. Just this spread is nothing. It's data which is in front of you. Then if you find the mean of this data, right? For example, this mean is somewhere here, okay? The mean is somewhere here. This is the mean actually. And this is a symmetric distribution. We will see what it is, what we mean by symmetric later on. Anyways, this is the data and we have a mean of this data. Now, half of the data lies on the left side of the mean, and half of 50% of the data lies on the right side of the mean, right? So the next thing is that if we move just one standard deviation away from the mean, so this is one standard deviation away on the right side, and this is one standard deviation away from the mean on the left side, right? Now, this will occupy 68% of your data. So if you have a data in front of you, for example, let's say we have a data here, birth data. Now, if you find the mean is 3.39. Now, if you add 0.55 to the mean, that's the standard deviation. And if you subtract 0.55 from the mean, let's keep it simple. Let's say we have a mean of 3 kgs and we have a standard deviation of half a kg, right? Then 68% of data will lie from in the range of 2.5 kgs to 3.5 kgs, right? So 70%, almost 70% of data falls within that range, right? This we need to understand, right? So we will do it in Excel later on, and we will find how we can really calculate it. And if you go 2 standard deviations away from the mean, we will get 95% data. If you go 3 standard deviations, now people from background of statistics will really question this empirical rule with some logic that this does not hold true every time, but in natural processes, in most of the cases, in majority of the cases which you are going to deal in future in terms of data which you are going to collect, this empirical rule stands true. For technical guys or people from statistics or mathematical background, this holds true for only normal distributions, right? Normal distribution, or the bell curve distributions, right? So this is going to help tell us something about how this data is spread, right? Now, you all may have heard about a standard that's called Six Sigma standard, right? Six Sigma standard is all about quality control and quality assurance. It's a standard which majority of the businesses use in manufacturing mostly, or in other financial industries as well. They use this standard which is called Six Sigma standard. What is the Six Sigma standard actually? It tells you that only 3.4 defects are allowed per million. For example, if you perform a million tests or a million operations, out of 1 million operations, only 3.4 defects are acceptable. And if you have more than 3.4 defects in a million, then you have missed, or you do not qualify for a Six Sigma standard, right? Now, why I have mentioned the Six Sigma standard here is, like, if you look at here, the standard deviation is actually, the term sigma is used for standard deviation. It's a short, it's kind of a, we have a symbol to represent other things. So for standard deviation, we have sigma. So why we call Six Sigma means 6 standard deviations away. Now look at this image in front of you. This mu is the mean, right? This mu is the mean. Now, 68.2, let's say 68% of the data lies within the first standard deviation. 95.46 of the data lies within 2 standard deviations away. 99.73 lies 3 standard deviations away. And then we have 99.9937, just 4 standard deviations away. And when you reach 6 sigma or 6 standard deviations away from the mean, you have 99.99999. It's almost 100, right? So if you have an outlier, or if you have a chance that, which you may call it a defect, there are least almost, it's impossible to get an error or an outlier 6 standard deviations, right? So how does what we understand by this is, if we go back to this birth data example, for example, we have a mean of 3.39 kilograms for a birth, a mean for the weight of a child at the time of the birth. Then 1 standard deviation away, let's say we have a mean is 3 only. And one standard deviation away means on a higher side we will take it is 3.5, and two standard deviations away means 4 kgs. But a child has or a baby has 4 kilograms of weight at the time of his birth. Then 3 standard deviations away means he has a weight of 4.5 kgs. 5 standard deviations away means he has a weight of 5 kgs, and kind of. Now, if you reach a 6 standard deviations away, the child should have a weight of around 6.5 kgs, right? And now, can we have, we really or rarely we find it, or we find a baby having a weight of around 7 kilograms or 6.5 kilograms, right? So if we take this childbirth as a process, so the defects, we can say defect means a child having an weight of more than 6.5 kgs is impossible, right? So if we take this data, we can be assured that the childbirth has a 6 sigma standard, because we don't have children. We rarely, or we never had a children of a 7 or 8 kgs weight at his birth. So this is a kind of standard which is already established in the childbirth data. So same we apply in manufacturing units, same we apply in financial, corporates and other things, right? I hope you understood what is Six Sigma standard. Six Sigma standard is nothing. It only allows you 3.4 defects per million. If you perform a million operations, 3.4 defects are allowed, and we can mathematically see why we call it 6 sigma. One standard deviation is 1 sigma, two standard deviations 2 sigma, and kind of thing. And when you reach a 6 sigma standard, you have 99.9998% of data there. So anything beyond that, okay, anything beyond that is impossible, right? So this is almost 100% of the data which you have. Also, just for your information, we have 5 sigma standards. Sometimes we have 4 sigma standards, and 6 is known to be the best of all, right? Okay. So we have some useful tips about standard deviations again. So we have, if you scale the data, so if you increase the data, uh, standard deviation will increase as well, right? And if you translate the data, now what do you mean with translate and what do you mean with scale? Scaling means you're multiplying with a constant, and translating means you're adding with a constant, right? So that I hope you know what's translating data and what is scaling data, right? And we will do it in Excel. So let's move ahead. Let's move ahead. So what is your actual weight? Each morning you weigh yourself on a scale, right? Each morning you weigh yourself on a scale. You are guaranteed to get a different number. I mean, say a different weight, right? What are the reasons behind this? The reasons which we have, enlisted here are just some of them, not all of them. The reasons may be when or what you ate ate means the previous evening what you had in your dinner. So that affects the current reading, and what kind of flatness of the floor is available, so that where you have put the scale is the floor flat enough to give you an accurate measurement or not. And you may have an actual change in your body mass because of some other things. So that is the actual variation in your weight. So reasons may be sampling error. Why sampling error? The first thing is the sampling error. Why? You cannot accurately or exactly calculate what you had previous evening, and you cannot, take a measurement, actual measurement. So that's a sampling error. And then the next thing is the flatness of the floor. Sometimes on a slightly elevated floor, you cannot get a good measurement, or a false measurement you may get, and also you may have a change. So whatever measurements you perform, you may have a variation, right? Now, before we conclude this means and standard deviations, I know we have still to do it in Excel, Microsoft Excel. I'll show you in a while. One thing you should remember and keep a note in your notebook right now is that whenever you are reporting about data, when you are going to characterize your data, or you're going to tell someone about your data, that this my data looks like this, you should always use two things, right? One is the mean and one is the standard deviation. So don't tell someone that my data has this much of mean. This is not going to tell him the whole story, or this is not going to, if someone tells you my data has this much of mean, this does not tell you the whole story. If you want to understand the whole data or the whole description of data, you should know two things, or you should tell someone two things. One is mean, where the center of your data lies, and second is standard deviation, how spread your data is, right? How spread your data is. So this is an important thing to note. Okay, now let's get a bit further. Now we have a problem sometimes that if we have data from two different data sets, right? For example, we have a source of data from the childbirths as we had, and another source of data we have from the, for example, we have from some other, financial organization. We have, data from the stock exchange or something else. So can we compare childbirth data with the stock exchange data? And sometimes you may ask why we need to do so. We have applications, or we have scenarios where we need to compare data from two different sources, right? So if we have data from two different sources, probably we won't find that both data or both data sets have the same spread or the same center. So how we are going to compare two different data from two different sources with different kind of characteristics? Now, this is a question which is usually asked once you try to characterize your data, once you try to understand your data. Sometimes you have a scenario, data comes from two different sources with different kind of set of characteristics, and you have to compare. Now, the question lies here is that how we are going to compare that. You may be knowing that we may have different kind of graphs, right? So we have some text. Just a second. Okay, we will do some. Someone has asked us to explain with examples, and we'll take those examples once we move to the Excel. Okay, so can compare data from different sources or different origins with different characteristics? Yes, we can. And but why we need to do so is we may have scenarios where we have to kind of compare the two different source of data, and we usually do this by plotting our data in different kind of plotting techniques. For example, we use some scatter plots, or we use some histograms, and we use some other curved plots, and we have to compare. Now, in order to compare data from two different sources, this is a very important thing. You must remember that we need to normalize the data. We need to bring data from different sources on a similar kind of scale, right? Scale the data from different sources on a single or a common scale, right? Now, how we do this? We use standard coordinates, right? This is an important concept. We use standard coordinates in order to bring the data from different sources on a single platform or on a single scale in order to understand the spread, in order to understand the diff data, right? We also call it standard coordinates, or we also call it as normalized data. People who are going to take on machine learning, data science, artificial intelligence, they will always find a term called normalized data. They will be asked to normalize data before they apply some sort of machine learning techniques, or before they go for making a machine learn. They will always be asked to normalize the data, right? Now, what we do and how we normalize data, we will see in Excel, but one thing you must remember, data from any source is normalized. Once we normalize data from any source, what we get is we will get a mean of 0 and we will get a standard deviation of 1. Any data from any source, you normalize it. At post normalization, you will have the data in standard coordinates, or you will have the data with a mean of 0 and a standard deviation of 1. Okay, so let's move to the Microsoft Excel and perform these basic things, right? Okay, so I guess we can have a break for a while. Or no, we can move on. So let's move to Microsoft. I've used a very basic, you know, Microsoft Excel application, which is not an advanced one, so that everyone is included. And maybe some of you may have previous versions of Microsoft Excel, so that everyone can do it. Okay, so before we break, we have 10 minutes. Let's do something which, for example, we have some data, and I'm just randomly plotting this data, and we have, so let's say we have this data, and this is a series of data. Let's say this is an attribute. Let's take an example. So, okay, let's say this is the grades. Grades out of 10 in a course. So this is grades out of 10 in a course which we have. Okay, so someone got 3 and 4 and 6 and 1, 9, 4, 2, 5 and 6, right? So the first thing, sometimes okay, let's start with the simple thing. Let's calculate how we are going to calculate the mean of this data, right? So we'll use the average. We'll equal to average, and then we are going to select this data. Here it is. So this is the mean. We got the data of this mean is the mean of this data is 4.44444 is the mean of this data. So the center of this data lies here, right? The center of this data lies at 4.44. So we got the mean. We can also calculate the mode of this data. We can write equal to, we can use mode, right? MODE mode, and we have to select again. Now what is mode? Mode is the middle or the central value of the data. So 4 is the mode. So see, it's always close to the mean as it should be. And we can also have the median, right? Which returns median. Okay. So median is all again 4, right? So median is the central term of the data, and this is the mode is the most repetitive or the most frequent element in this data, right? So we can say this is the mean, this is the mode, so this is the mode, mean, and median of this data. See what we found. We randomly plotted some data, and we found they all tell something about the center of the data. So the data in front of you, we have center of it, right? We have mean, we have mode, we have a median. I'm just taking a very basic example of finding mean, mode, and median. Now, before we go further, let me give an understanding of the difference between the mean, mode, and the median. Is that mean always tells you something, it gives an exact or a continuous value or a fractional value at times it gives you. But mode and median will never give a kind of data or a kind of value. See, 4.4, there is no 4.4 value here if you look at this list, right? But mode, it's found here. Median gives kind of a value which exists in your data, right? And mean may not give you the exact value or a kind of value which exists in your data. So you have to figure out when you use mean, you have to figure out when you use mode and median. But the safest way of determining the center of data is using the mean, right? Okay, let's move further. Let's try to find the spread of this data, how spread this data is, right? Let's go and calculate the standard deviation of this data. How will you calculate standard deviation? We say equal to standard deviation. Now, standard deviation have some variations as well, but I would suggest you all of you to use the Excel, this one, standard deviation P, with a P, because this is for population, right? So this one, this one you should use to calculate the standard deviation spread of the data. Okay, let me start this. Okay, so this is the standard deviation, how spread this data is. This gives an idea of how spread the data is. The standard deviation for this data is 2.26662309. Right, so this I will say standard deviation. So this is standard deviation of this data, right? So this tells you how spread the data is. So how spread the data is from the mean, right? What's the mean? Mean is 4.44, right? And the one standard deviation ever means 2.4. Let's do one more thing. One more thing we will do is, so this is how we calculate standard deviation. Second thing is, can we normalize this data? Normalize means we should have a mean of 0 and a standard deviation of 1. Can we normalize this? So yes, we can. We have steps to normalize, but we will use a function in Excel to simply normalize this data. To normalize this data or to standardize this data, we use a function that's called standardize, right? See, this is a standardized function. This is standardized function. And then you have, what are the arguments you need to tell him? You need to tell him about the mean. So the mean was 4.44, right? Okay. Okay. And okay, let's do like this. Okay, let's standardize the data. So we normalized. It's equal to standardize, and then we have to write the x, which is this is the x. This value we have x. Mean we have 4.44, and the standard deviation is 2. This is the standard. So A40. So see, I will drag it. Okay. So this is $A, $B. Okay. Put a dollar here. Dollar here, right? A2. Okay, anyways, we are breaking, and we'll take a break of 2 minutes and we'll join again, and then we will continue with this. I'll find Sarah and I will come back. Let's join after 5 minutes so that we can have another Zoom call as well. Thank you so much, and let's break and join again.